welcome to the program. Your teacher today, my name is STIPLATON. So I'll be taking you through primary school science. So feel free, and I hope you have some writing materials to be able to take any relevant notes that you'll come across. So our topic or our subject for the day is science, and we want to look at a topic called plants. Want to look at the topic called plants, and more specifically we'll be looking at reproduction in plants. So when we talk about reproduction in plants, we'll be focusing much on a flower, because a flower is the reproductive part in a plant. So we start by defining reproduction, that is the giving rise to new offsprings. So in plants, the offsprings will be given rise through the flower, which is the reproductive part. So I want to draw a diagram to represent a flower. Then we will be discussing about the flower. So I am drawing a diagram of a flower, and that is where our lesson will be based on for today. So I have drawn an example of a diagram that represents a flower. I believe all of you can see that, the viewers. So this is what we call a flower, and a flower has different parts. So I'll begin by naming the parts of the flower. So we have this part, and that part is called the anthers. That first part of the flower is called anthers. So we have this second part. This one is called the filament. So we have the anthers, we have the filament. The next part is that we call it the stigma. That is called stigma. So we come to the next part, which is called the style. That part is called the style. We come to the outer part here. The outer part is called the petal. Collectively, petals can be called corolla. Collectively, the petals can be called corolla, or the other name of the petal is corolla. We have the sepal. This one is petal, but this one is sepal. So the sepal collectively can be called calyx. The sepals collectively can be called calyx, or if you are likely to be asked by an examiner, for example, what is the other name of the sepal? That is the calyx. We have this part is called the ovary. So we have the ovary. Inside here, we have the ovules. Inside the ovary, we find the ovules. Then we have the stalk right here. We have the stalk. So those are the parts of a flower. We have the anthers, if I may repeat. These are the anthers. We have the stigma, which is right here. We have the filament. We have the petals. We have the style. We have the sepals. We have the ovary. We have the ovules. And finally, we have the stalk. Since I've said that the flower is a reproductive part of a plant, then we are also going to see if it's a reproductive part, it means then there are male and there are female parts. So for reproduction to take place, we usually have the male and the female sex cells that are involved. So after they fuse which will be the reproduction. They now give us the new life springs. So even in a flower, we have the male parts of the flower and the female parts of the flower. So the male parts of the flower will produce the male sex cells in a flower, which we will come to understand that the male sex cells will be called the pollen grains. Then the female parts of the flower will produce the female sex cells, and we'll understand that the female sex cells will be called the ovules. So let me draw the male part of the flower. The male part of the flower. So that is the male part of the flower, a diagram to show that. So the male parts will have the anthers, and then we will have the filament. Those are the male parts of the flower. So if you look at the original diagram, this drawing alone as part of the whole diagram represents the male parts of the flower. So we have the anthers and the filament forming the male parts of the flower. When we come to draw the female parts of the flower, we draw the female parts of the flower only. So the female part of the flower will be found at the central of the flower, inside the flower. So the female parts of the flower gives us the stigma, it gives us the style, it gives us the ovary, and finally it gives us the ovules. That forms the female parts of the flower. We have the stigma, we have the style, we have the ovary, and finally we have the ovules. So in these male and female parts of the flower, let's look at the functions of each of the parts of the flower. So when we come to the anthers as one of the male parts of the flower, the function is they produce pollen grains. They produce the pollen grains. That is the function of the anthers. They produce the pollen grains. And pollen grains, these are the male sex cells. These are the male sex cells of the plant. So the pollen grains are the male sex cells of the plant, and they are produced by the anthers. The filament supports the anthers. The filament supports the anthers. It's the one that puts the anthers into position for them to produce the pollen grains. So the work of the filament is to support the anthers. So those are the two parts of that form the male parts of the flower. We have the anthers, which produce the pollen grains. We have the filament, which supports the anthers. That is about the male parts. So we look at the female parts. We have the stigma. So the stigma receives the pollen grains. The stigma receives the pollen grains. The stigma receives the pollen grains. And we have already said that the pollen grains are produced by the anthers. So once they are produced, they are received by the stigma. So the function of the stigma is to receive the pollen grains. Style, it supports the stigma. Supports the stigma. The function of the style is to support the stigma. In male parts, the filament was supporting the anthers. But when we come to the female parts, the style will now support the stigma. Now, the ovules form the female sex cells. Female sex cells. The ovules represents the female sex cells. So for fertilization to take place, there must be that fusion of the male on one side, the female on one side. When they come together, they join up, and then we say reproduction has taken place. So it is the pollen grains, the sex cells of the male, and ovules, the sex cells of the female, that will join. Then we have the ovary, which keeps the ovules and it develops into a fruit after fertilization. That is the male parts of the flower and the female parts and their functions. So we can also look at the other functions that are found, the other functions of the parts of the flower. So we have talked about anthers already. We have talked about the stigma. We have talked about the petals, the filament, I mean. So let's look at the petals. What is the function of the petal? The petals are the ones that are found outside. Anytime you look at a flower, the bright color that you see, depending with the type of a flower. For example, if it is a rose flower, you're likely to see a red color. The red color that you see, that is the color that represents the petals. That is the color that represents the petals. So the function of the petals, especially in insect-pollinated flowers, is to attract the insects. We'll also look at pollination. We have looked at the function of the style. So we look at the function of the sepal. So the function of the sepal, is to protect sepals. They protect the flower. They protect the flower in a bud stage. In a bud stage. They protect the flower in a bud stage. Bud, B-U-D. B-U-D. Bud stage. Bud stage is the stage before the flower opens up. That is what we refer to as a bud stage. So the sepals are the ones that protect the flower. They cover the flower before the flower opens up. That is the function of the sepals. And they are usually green in color. They basically so we are continuing. I was giving the functions of the other parts of the flower. So I will repeat about the sepals. The sepal protects the flowers in a bud stage. The sepals protect the flower in a bud stage. And a bud stage is a stage before the flower opens up. Before the flower opens up. That is what is referred to as a bud stage. So the sepals collectively are called calyx, and they are usually green in color. And their function is to protect the flower in a bud stage. Then we have the stalk. The stalk is the one that attaches the flower to the plant. Attaches the flower to the plant. So the stalk attaches the flower to the plant. Those are the functions of the parts of a flower. So maybe I can go through them once again very quickly. The anthers, which are male parts, they produce the pollen grains. The filament, which are also the male parts, they support the anthers. The stigma, which are the female parts, they receive the pollen grains. The style, which are also part of the female parts, supports the stigma. The ovary will develop into a fruit, and the ovules are the female sex cells which later develop into seeds. The other parts, we have the petals, also called corolla. They attract the insects in insect-pollinated flowers. And then we have the sepals, collectively called the calyx, which protect the flower in a bud stage. Then finally we have the stalk, and the stalk attaches the flower to the plant. So those are the parts. Male parts of a flower, they are given one name, and also the female parts of the flower have one specific name. So for the male parts of the flower, male parts of the flower will be called stamen. Stamen, those are the male parts of the flower. The female parts of the flower will be called pistil, or the carpels. Those are the female parts of a flower. Male parts, to be able to remember or memorize, they have the word men. So if they have the word men, then that definitely tells you that those are the male parts. So you can use that to memorize men for male parts. So the stamen are the male parts. The female parts will be called the pistil or the carpels. So after looking at the parts of the flower, we want to look at what we call pollination. And what is pollination? So pollination. So we've been talking about the male sex of the flower, the female sex of the flower. So pollination will be that movement of the sex cells, especially the male sex cell. So when we look at pollination, we first of all define what is pollination. So pollination, by definition, is the movement. Pollination is the movement of the pollen grains, from the anthers to the stigma. That is the definition of pollination. So pollination is the movement of pollen grains from the anthers to the stigma. That is what we call pollination. There are things that make it possible for pollination to take place. There are things that make it possible. We'll call them agents of pollination. There are things that make it possible for pollination to take place. They will be called the agents of pollination. So we have several, but we look at two mainly. So we'll have wind as an agent of pollination, and we will have insects. Now, pollination being movement of pollen grains from the anthers to the stigma, then it means there must be something that will facilitate the movement, or there must be something that will enable the movement of the pollen grains from one side, which is the anthers, to the other side, which is the stigma. So whatever means the pollen grains will move is now what we are referring to the agents of pollination. So we are going to look at two of them, which are insects or wind. So we are going to see what's the difference. Why should this flower be pollinated by insects, and why should this another flower be pollinated by wind? So in the two, we are going to look at insect pollinated flowers, and we're also going to look at wind pollinated flowers. So insect pollinated flowers will be different from the wind pollinated flowers, and the difference will come based on their characteristics. Characteristics are how are the things. Why will this one be big, this one will be small? Why will this one be bright, this one will be dull? So that leads us to the characteristics of the insect pollinated flowers and the wind pollinated flowers from the two agents of pollination. So those flowers that are pollinated by insects, we will refer to them as insect pollinated flowers. Those plants that those flowers that are pollinated by wind, we will therefore call them the wind pollinated flowers. So let's look at the comparison between the two. We'll be looking at insect and then wind. So 1 point for the insect, 1 point for the wind, because the two tend to be the opposite of each other. So we look at the two types of pollination, the two types of agents, not type of pollination, but agents of pollination. So that gives us 2, which is insect pollinated flowers, which means their agent of pollination is insect, and then we have wind pollinated flowers, which means the agent of pollination is wind. And I will draw a diagram, a table so that we can see the comparison. So the first one, about insect pollinated flowers, they are brightly colored. Brightly colored. If you have been following my lesson very well, when I talk about brightly colored, you definitely know which part specifically, which part of the flower am I talking about. So I'll ask you, I know I can't hear your answer, but you can just answer. So the brightly colored part is going to be the petal. So their petal are brightly colored. So one characteristic of the insect pollinated is brightly colored. It is not enough to know the characteristic, it is also good to know why is it the way it is. So brightly colored, in order to attract the insects will easily see a bright colored flower rather than a dull colored flower. So the characteristics for the wind will be the opposite. If this is brightly colored, then here we are going to get dull colored flowers or dull petals. So brightly colored to attract the insect. Number 2, they produce nectar. So insects like bees feed on nectar. So as they are in their business looking for nectar, in the process of looking for nectar, they are going to allow pollination to take place. As they move from one flower to the other, they carry the pollen grains from one flower and deposit at the stigma of the other flower. Wind pollinated flowers do not produce nectar. Number 3, insect pollinated flowers, they have a sweet scent. Scent here means smell. So it is just as the same as saying they have a good smell. It is the same when we say that. So they have a sweet scent. That sweet scent or that sweet smell will attract the insect to come to the flower. They have a sweet scent. Wind pollinated flowers do not produce scent. Number 3, characteristic of insect pollinated flowers, they are large in size. So why will they be large in size? They are large in size in order to allow the insect to fit inside the flower. Remember, if the flower is too small, the insect will not get inside the flower. And for pollination to take place, the insect must get inside the flower. So they are large in size to allow the insects to get in. The wind pollinated flowers will be small in size. They are small in size. Number 5, the anthers and stigma the anthers and stigma are found inside the flower. Are found inside the flower. The anthers and the stigma are found inside the flower. Wind-pollinated flowers, the anthers and stigma. The anthers and stigma hang outside. The anthers and stigma hang outside. Now, the stigma and the anthers in an insect-pollinated flowers will be found inside the flower because the insect has to get in. That's why they are found inside. For wind-pollinated flowers, if the anthers are inside the flower and the wind is blowing, if this is your flower and the anthers need to hang outside, because as the wind is blowing, it will be able to blow away the pollen grains and then they will move together with the wind. Remember, the definition of wind is moving air. So as the anthers are hanging outside, once the wind blows, it blows away the pollen grains. And as the pollen grains are being blown away, they'll move from one flower to the other. And then pollination will have taken place. Number 6, they have a flat and sticky stigma. They have a flat and sticky stigma. So with wind-pollinated flower, their stigma is not sticky. Stigma is not sticky. Now, for insect-pollinated flowers, the stigma is flat to enable the insect to land. So the reason why the stigma is flat in an insect-pollinated flower is to give the insect a good landing surface. So as it's looking for the nectar, it can easily land on the flower. And it is sticky so that in case the insect is carrying some pollen grains in the body, the pollen grains will stick in the stigma. And that does not apply to wind-pollinated flowers. Number 7, they have sticky pollen grains. Sticky pollen grains. They have sticky pollen grains. For wind-pollinated flower, the pollen grains will be not sticky. Why are the pollen grains in insect-pollinated flowers sticky? They are sticky to be able to stick in the body of the insect. Remember, as the insect is doing its business, the purpose of the insect does not know that it is pollinating the flower. For the insect, it's looking for the nectar. So in the process of looking for the nectar, the anthers, which produce the pollen grains are going to be very sticky and they will stick in the body of the insect. So that is why the pollen grains need to be sticky. The last point, for wind-pollinated flowers, they produce a lot of pollen grains. They produce a lot of pollen grains, the wind-pollinated flowers. Why should they produce a lot of pollen grains? Because as the wind is blowing away the pollen grains, most of the pollen grains are going to drop along the way. Therefore, it needs to produce as many pollen grains as possible, such that even if we'll have some of them which will drop, at least majority will land onto the next flower. That is why they produce a lot of pollen grains. Now, these pollen grains in insect-pollinated flowers will not be as much as those in the wind-pollinated flowers. That gives us the characteristics of the insect and the wind-pollinated flowers. I started by defining pollination, which was the movement of pollen grains from the anthers to the stigma. Then I talked about what makes that movement possible, and we call them agents of pollination. And we looked at 2, insect and wind. So this gives the characteristics of insect-pollinated flowers, and this gives the characteristics of wind-pollinated flowers. So when we come to pollination, these are agents, but we also have types of pollination. We talk about types of pollination. Types of pollination. Under types of pollination, we are going to get two types of pollination. One, we'll call it self-pollination. One, we'll call it self-pollination. And number two, we'll call it cross-pollination. So looking at the types of pollination, we get two types of pollination: self-pollination and cross-pollination. Since we know what pollination is, we are going to look at the difference between self-pollination and cross-pollination. The difference between self-pollination and cross-pollination, we look at the plant. So in self-pollination, we have the movement of the pollen grains in a specific plant. The flowers might be different, but the plant has to be one. But when we come to cross-pollination, there must be two plants that are involved. So there must be two plants, but of the same kind. So let's define what self-pollination is. So self-pollination, the movement, that is the movement of pollen grains, the movement of pollen grains from the anthers, to the stigma, from the anthers to the stigma of the same plant, Self-pollination, the movement of pollen grains from the anthers to the stigma of the same plant. So in a diagram, a sketch of a diagram, just to emphasize what self-pollination is. In a diagram, to emphasize what self-pollination is, we'll get something related to this. So we'll have one plant. So we can have, that is a flower, that can show a flower. So it must be movement of pollen grains from the anthers to the stigma. If you look at the plant, this is just one plant. So this is what we call self-pollination. Self-pollination. It can either be one flower or different flowers, but the idea is one specific plant. So let's define what cross-pollination is. Cross-pollination. Cross-pollination. So cross-pollination will be the movement of pollen grains, from the anthers to the stigma, from the movement of pollen grains from the anthers to the stigma of another flower in another plant, but of the same kind. The keyword here is the same kind. So cross-pollination is the movement of pollen grains from the stigma of another flower in another plant to the other plant, but should be of the same kind. So in cross-pollination, we are going to have two plants that are going to be involved, unlike self-pollination. So we are going to have two plants that will be involved. That will be plant number one, and that will be plant number two. So we can have this example to show a flower, and we can have this another example to show a flower. So when pollen grains move from this flower to that flower, this is now referred to as cross-pollination. That is referred to as cross-pollination. We have movement of the pollen grains from one flower to the other flower. The plants here are two. This is plant one, and this is plant two. So we have two plants, but remember the plants have to be of the same kind. If this is a maize plant, this one should also be a maize plant. So the plants have to be of the same kind. So that now will be cross-pollination. So if we look at it diagrammatically, this will be cross-pollination, two plants. This will be self-pollination, one single plant. So that is about pollination, cross-pollination, and self-pollination. So the cross-pollination can either be wind, insect. Self-pollination is mainly insect. That gives us the pollination. So let's look at now the process of fertilization in plants. The process of fertilization. Remember I said our topic is about fertilization in plants, and we have started by looking at the female reproductive sex cell, which is the flower is the reproductive part in a plant. We have looked at the parts of the flower. We have also looked at the functions of the parts of the flower. We have categorized the parts of the flower into male and female. We have looked at their importance. We have looked at the movement of the pollen grains from the anthers to the stigma. And we have seen the agents of pollination. And then we have looked at the two types of pollination, that is insect pollinated and wind pollinated. Then the final thing that we have looked at is types of pollination, and we've seen we have two. We have self-pollinated flowers, which will be on one plant, and then we have cross-pollinated flowers, which will be two different plants. So we look at now the fertilization process. Fertilization process. So for fertilization to take place, there must be movement of the pollen grains. So the first process, so I'll draw the male parts, the female part here, and I will draw the male part here. So for fertilization to take place, the first process number one, I will write here, pollination has to take place. That is the first process. So it means pollination has to take place. The pollen grains must move from the anthers to the stigma. So this here represents the pollen grains. Pollen grains. So we'll need to have pollen grains. So pollen grains must move for fertilization to take place. So the first process is pollination. Movement of the pollen grains from the anthers to the stigma. Now, process number two, we talk about germination of the pollen grains. Germination of the pollen grains. Germination of the pollen grains. Germination of the pollen grains takes place in the stigma. So germination of the pollen grains. Once the pollen grains reach here, they start to germinate. So the next process that happens in the stigma is germination of the pollen grains. Germination of the pollen grains. To investigate this, we take a salt solution or sugar solution, but the most preferred is sugar solution. You take sugar solution and then you Germination of the pollen grains. So germination of the pollen grains takes place in the stigma. And to investigate this, you can use you can do it practically, whereby you take sugar solution. So this is sugar solution. Sugar solution. Sugar solution is a mixture of sugar and water. The sugar will dissolve in the water. Then you cover. When you cover it, and then you drop here some pollen grains. Some pollen grains here. They will start to germinate. So this is pollen grains. That is how we can investigate that. So germination of the pollen grains, that is our step number 2. Step number 3 is growth of the pollen tube. Growth of the pollen tube. Growth of the pollen tube. So once the pollen grains have germinated, there will be a tube that will grow. So the pollen tube grows in the style. Germination takes place in the stigma. So this one will refer to it as pollen tube. Pollen tube. Growth of the pollen tube, that will be the pollen tube. So the pollen tube will grow. It will grow downwards. So down here, we have the ovary and the ovules. So pollen tube will grow and grow and grow. So once it reaches here, it gives us the 4th process, which is breaking of the pollen tube. Breaking of the pollen tube. Breaking of the pollen tube. So the pollen tube breaks. After the pollen tube has broken, it releases the pollen grains. Remember, the pollen grains are here now. It releases the pollen grains. So the breaking of the pollen tube. After the pollen tube breaks, then we have fusion. Fusion. So fusion is the coming together of the pollen grains and the ovary. So at this point, we say fertilization has taken place, and that is the process of fertilization in plants. So this has been the lesson. The lesson was based on fertilization of plants, and this is a very common area tested in the exams, especially the syllabus that is just ending the 844. So these are very important concepts that need to be well factored in. So let me go through the process of fertilization as I conclude. So we have pollination, we have germination of the pollen grains, we have growth of the pollen tube, we have breaking of the pollen tube, and then we have the fusion. So that marks the end of my lesson on fertilization of plants. I have been your teacher, Mr. STIPLATON. So enjoy the rest of your day and see you some other time. Have a good day.
Lola ni programu inayokupa fursa ya kutizama video zozote pindi tu unapokuwa na nafasi. Hadithi za kukupa motisha, drama, maisha ya vyuo vikuu, teknolojia, masuala ya jamii, kuzuru maeneo tofauti, spoti,